great to have you today, Boaz. Yeah, the stage is yours.
Thank you, Amit. Welcome everyone, and thanks for having me in the community. I don't know if you can see the screen share. Amit, is the screen share? Okay, there we go. Okay, perfect. Thanks. So I'll jump into it from here. So my name is Boaz Bechar. I'll be speaking about root of trust and bearer asset inheritance, particularly in the digital asset space. And I'll cover some adjacent topics such as self-custody, seed storage, disaster resilience, and we'll try to answer a question that I've been thinking about for a long time, which is, where do you store the password to your password manager? Another password manager, but then, where do you store the password to that, and so on and so forth. So I've spent the last couple of years, I think, thinking about this and struggling with this topic. And I think I've settled on a pretty good approach for personal root of trust management. And I think it's something that each one of you in the community would be able to apply today to improve your security posture for yourself, for your family, and potentially for future generations, as we'll see how this can be applied in different ways. But before I jump into the details, I'll share a few words about myself and my background and what led me to working on this topic. And I'll, just another preface this that say that it's completely free, it's open source, there's no commercial pitch behind this or any sponsors or anything like that. So about myself, I'm 42, father of 2 young boys. My background is in software engineering and technology product management and development. And over the past 10 years, I've had the opportunity to work on a few different products in the crypto space, including consumer wallet technology, developer tooling, and most recently, institutional custody technology and security architecture. So I led a startup in 2014 where we developed a multi-platform self-custody wallet, developer tooling like APIs, and we also operated a popular block explorer. At least it was popular at the time. And those products were all rebranded in 2016 to BTC.com. And that's the brand that we operated on after Bitmain acquired the company. And I spent a few years at Bitmain growing BTC.com to over 1 million downloads and billions in transacted value on the platform. And I spent the last couple of years, 6 years, working at a global bank on institutional digital asset custody and cyber security innovation. And during my time at the bank, I had the chance to register 3 patents in the digital asset space. So 2 of them related to cold storage, and one of them related to UTXO selection or coin selection concepts. And these days I'm working on something new, but it's unrelated to what we're speaking about here, and I'll be able to share more in due time. But for anyone that's interested in following along, my Twitter, X, or LinkedIn, or whatever, more than welcome. Okay, so jumping into our topic here. Being in the Web3 community, I think we're all self-custodians of varying degrees here. Hardware wallets, mobile wallets, browser extension wallets, right? We're all key managers in some sense, key owners and key custodians. But I think for me, at least, after having young kids, you start thinking more seriously on how to manage these bearer instruments going forward. And a personal story. So I remember a night laying in bed when my oldest kid was just a few months old, and you run through the threat models in your mind. Should anything happen to me, how could I ensure that the assets survive until my kids come of age, right? It's called the bus factor, more plainly. What happens if you get hit by a bus tomorrow? But in an institutional setting, this would typically be called, disaster recovery or continuity of business. And of course, in an institutional setting, you would have carefully planned playbooks that are rehearsed biannually, and so on and so forth. But for you and I, us self-custodians, it's still very much a Wild West, I think. And I'll go through the options later, and we can see how people have been thinking about it and what our options are. So thinking about how my family would take care of the keys without me, I got to think about the many items that have been passed down to me, which I've managed to lose over the years, right? So I'm still looking for that watch that my uncle gave me for my bar mitzvah when I was 13, right? And my father's special brown jar that was gifted to me, and my grandfather's stuff. So it's really, really hard to keep things safe over a long period of time, many years, and I deeply cared about that brown jar, right? But life happens, you move houses, you move continents, and it's just difficult. But I did get to thinking about the stuff that did remain over the years, and I have two excerpts of it right here, such as this letter that I received when I was 5 years old, certifying that I planted a tree in Koshmayao. Right? Don't ask how or why I still have this thing. Or this letter that I received when I was 3 years old, inviting me to a birthday party in New York. So, I think the point is here that really paper survives surprisingly well for a very long time. These papers are 40 years old and they're still here. So I was kind of surprised by that. But when I started digging into it, I learned that even the largest institutions in the world and the largest custodians that we know of in digital assets use paper as a final and ultimate form of backup for cryptographic material. So a classic example is how Coinbase operated back in its early days. In 2012, they published a blog post outlining how they used paper and QR codes and binders located in safety deposit boxes, as well as a blog post in 2018. So for some time, paper was a form of backup. And I would say that if your personal self-custody setup can mimic that of Coinbase 10 years ago, then you might have a chance of making it anon. But now, of course, Coinbase has advanced over the past 10 years and adopted MPC and cross-domain guards and other technologies. So I have no idea if this is their current standing practice, but I would not be surprised if paper was in circulation in some form still. And then, as a matter of anecdote, at BlockTrail, the wallet company we ran in 2014, our wallet infrastructure was based on a 2 of 3 multisig, and we were co-signing our users' transactions. And our co-signing key was backed up in a similar way, right? So it was on both USB drive as well as paper, and located in a safety deposit box in our underground facility. So this is not an unusual form of backup. That's the point I think I'm getting to here. But another, I think the biggest example that everyone always looks to when looking at key ceremonies or root of trust is the ICANN DNSSEC root ceremony. And this is the thing that lets your browser verify that the domain's records are authentic, right? It's the closest thing the internet has to a master key for trust. And it has no single owner. And it requires a quorum of approvers to physically gather around and perform a ceremony. And so this is performed and filmed and live streamed on the internet and scripted to the word. The key material here is backed up on smart cards, similar to USB drives, and placed in tamper-evident envelopes and locked in safes. And so we'll take a look at this 1-minute video together just to have a taste of what a institutional key ceremony looks like and the form of backup and lengths that are taken. And so in this video, I'll just say there are 2 safes here in the bottom right, safe 1 and safe number 2. There's a room of people observing the 2 hosts that are performing the ceremony or guiding the ceremony. And yeah, let's take a look at it.
These and 2 OS Media micro cards into a plastic case. I'm just going to pick these 2 at random. I did place the plastic case containing 2 HMFDs and 2 OS Media micro SD cards along with 1 sheet of paper. Into the tab and seal it. sealing strip. The bundle, nice and sealed. Good. Step 5.9 is complete.
All right, the next one is the CO4 Keeper Smart Card Set 2. It is intact and it is Bravo 0263839.
Good.
And I will put that in the safe.
All right. So that's a pretty serious root of trust ceremony right there. But institutions aside, what are most people like you and I actually doing in practice for disaster recovery? There are over 5 million hardware wallets sold worldwide, and tens of millions of mobile and web wallet users like ourselves, right? And it's important to make a distinction between the signing mechanism itself, be it a hardware wallet or a mobile wallet, and the key and its backup. Right? A hardware wallet is a signing device. It's not a device for long-term storage. That's why it ships with a little card for you to write the seed down. Right? 3 wrong PIN codes in your hardware wallet and it locks up. So that's kind of stressful. Plus, it's hard to rely on hardware surviving unused over tens of years due to bit rot, right? It really does not survive for a long time. So what do most people do? I think most people just write down the seed phrase, right, and keep it at home. I think that's the typical setup. But storing any bearer asset at home is asking for trouble, right? It doesn't really survive a fire or a flood or any kind of basic disaster or basic threat model. And I would think of it as kind of similar to stuffing digital cash under your mattress, right? So potentially there are tens of millions of people out there that have basically, digital cash under their mattress, and they are at risk of, a basic disaster happening. So they could use a basic disaster recovery plan. But for those of us that do go through the effort of setting something up, something more sophisticated, I think the popular mechanisms are, at least that I've seen, are splitting the seed phrase into 2, right, and placing them in different locations. One in a safe here and one in a safe there. But of course, you've kind of increased your attack surface area. You now have 2 locations that you need to secure. If something happens to either location, then it's complete ruin. And then there are people that are, ordering kits to engrave the seed into metal plates, and in doing that, which would survive the specific house fire incident. But I guess if you're based in the Middle East, you have the ballistic missile threat, right, which is a good example of something a metal plate might not survive. Or even simply, the evil maid attack, or just like a basic theft. So these are risks that still exist. But other approaches tie you into the mechanics of the specific chain and the protocol, such as on-chain multisig. A lot of people are doing on-chain multisig, or time lock transactions that involve signing a transaction that ahead of time that gets broadcast later on if there's a recovery situation. But these really tie you into the specific chain, into the recovery of the specific chain. And then, of course, you could just buy the ETF and give up self-custody, right? But that's not what we're here for today, and that's not an option. So I didn't find any of these common approaches ideal for me. I needed something for myself that was chain agnostic, something that could potentially survive long-term uncertainties like protocol changes and forks, something that can hold up against a basic threat model of a home fire, a theft, or basically one of the locations being destroyed or inaccessible, as well as something that can survive for many years, tens of years potentially, right? And I also, did not want to burden anyone with having to secure or remember a single password, right? But another vector that we all need to think about is insider risk, right? But what does insider risk look like for the self-custodian? Can you really trust yourself, right? Think about the last time you misplaced your car keys, or I lost my father's jar. How can you really trust yourself to keep something for tens of years? The bus factor, right? What happens if you become unavailable for whatever reason? So self-custody, while being a great privilege and has many advantages, it also can be a great burden. So why place that burden on those closest to you, right? With best intentions in mind, insiders handling bearer assets can unintentionally introduce risks, first-party risks, third-party risks. And I hardly trust myself with self-custody. So do I really want to burden my family with the responsibility of holding on to a scribbled piece of paper and to protect it from cyber attacks, physical attacks, thefts, wars, natural disasters, no shortage of things. But the physical threat, that's one that I think last year was talked a lot about, particularly because Jameson Lopp, the legendary internet persona and legendary Bitco engineer, former at least, and co-founder of Casa, he has a GitHub repo that tracks physical attacks in the crypto space, known as the wrench attack. And that repo tracks over 300 attacks since 2014, and most of them, a big portion being in 2025, being the worst year on record. So the threat model is real, disasters are real, and the physical threat is real. But what if the seed didn't need to exist in a single place, right? What if there was no crown jewel to steal? What if you could build a safe that was geographically distributed and disaster resilient by design? Enter social recovery. So social recovery is kind of like a digital social security program. Apple has it. They've had it for many years. If you can designate recovery contacts or trusted contacts in Facebook and Apple and many large platforms. In case you lose the ability to access your account, the trusted contacts can help you as a recovery mechanism, as well as for succession. So you can do something similar with your wallet seed phrase and other secrets, right? You don't need to be tied down to the platforms. And Vitalik, needs no introduction. He's written and spoken about social recovery for crypto wallets for years, and he's a big supporter of the concept. And I can't say for certain, but I would imagine that he's also a social recovery practitioner himself. Right? He said, a human brain is quite poorly suited for remembering passwords and tracking paper wallets, but it's an ASIC for keeping track of relationships with other people. So you can know that where you kept your key shards in a form of relationship instead of a specific location. But the good thing about social recovery is that it doesn't really need to be very social. You can control the key shards yourself, right, and just geo-distribute them. You can do a 2 out of 3, a 5 out of 10, right, where 5 keys out of 10 are required to unlock, and that gives you, the ability to lose over 50% of your keys and still recover, right? And you can do a 10 out of 20. Basically, you can go wild and come up with any threshold setup that works for you. And you can, distribute shards in different safe deposit boxes around the country, or even go further and distribute them around the world. But of course, you'll need to consider that in a recovery situation, what you'll need to go through in order to get that recovery. The primitive really is social recovery, and how you apply it is completely custom to you and your threat model. So a few years ago, I started looking for a threshold cryptography library where I could build an MFN social recovery setup for myself, right? I didn't find any solution off the shelf that really fit what I was looking for, so I set out to make my own. And Honestly, if there was something out there, I'd probably build it anyway because I like building. But my product requirements were pretty simple. I needed to encrypt secrets offline and store them offline. And I needed it to work both in digital and paper form because I knew that paper can hold up. And I needed a way to split the secret into parts. Right? So naturally, I started looking for a Shamir Secret Sharing library to perform the threshold encryption bit. And I came across two main libraries at the time. And in the current latest implementation, I'm using Privy's twice audited library. It has 0 dependencies. It's been audited by 2 independent different, I think, firms. And it's a really simple implementation of secret sharing library in JavaScript. So what I did is I built a paper-first UX on top of it, according to a basic flow that I needed, which was creating vaults, minting keys, and then recovering them by scanning each key share. And in the recent weeks, just like a couple of weeks ago, I had the time to productize the solution that I've been using for years and really release it as open source, mainly as a way to preserve the code and to make sure that it endures, available on GitHub for myself and whoever may need it in the future. But also to get feedback on the project and see if anyone has things that I have not taken into consideration or have not thought about, or improvements in security. So it's definitely welcome for contribution. The project is called PaperVault. The code is available on my GitHub, and I'll take you through a live demo in just a moment. But what it lets you do is quickly encrypt paper-based secrets in vaults with custom thresholds that you can distribute on paper or digitally. So it works completely offline, and it's ideally would be set up on a offline workstation or on an offline computer that you would set it up once, disconnect from all networks. You would hook it up to a cable, to a printer with a cable, and then you've got a fairly decent setup for creating personal encrypted vaults. But you can think of it as a kind of like a poor man's ICANN DNSSEC ceremony, like we saw earlier, right? Where they have, that ceremony is quite extensive and for the entire internet, and you can do something that's very similar just for yourself at home, right? And how far you want to go is up to you. You could order a Faraday tent and do it in a tent, but honestly, if you're doing it offline with a printer, you should be good. And of course, if you're in Israel and doing it in your mamad, then you're even that much more secure, right? So what goes in a paper vault? So when I started using this, I discovered that it's good for a lot more than just wallet C phrases, right? It's the perfect place to store 2FA recovery codes. So these like this screenshot right here is 2FA recovery codes. These funky looking codes that you get when you enable 2FA on practically any service like a GitHub or any SaaS. So suddenly I had a safe place to keep my 2FA recovery codes. And then I got myself a new laptop. I open it up. I have a disk encryption key that it gives me. So now I have a place to store my disk encryption key. And basically anything that doesn't naturally fit in a password manager, right? Like the password to my password manager. I finally had a place to store it, right? And this is what I consider a personal digital root of trust. It's the foundational layer of security from which everything else is recoverable from. So let's talk a minute about cyclic dependencies in password management. Just because this is a trap that's easy to fall into, and it's solvable now that you have a paper vault acting as your root of trust. So as an example, Jane is on vacation in Venice, and she's taking pictures of the city when suddenly the grip comes loose on her phone, and it falls into the water. So she walks into the Apple store naturally the next day and buys a new phone. But she realizes the password to her Apple account is stored in her password manager. So she goes to her password manager's website and she realizes she needs 2FA to log in, but the 2FA app is on her phone. So this is a cyclic dependency, and it leads people to getting locked out of their accounts all the time. And it's the exact reason you need a root of trust, and it's the exact time you would reach out for this, break glass recovery tool. Another classic example of is the Authy app. I don't know, probably a few of you know it. It's a 2FA recovery. It's a 2FA. It's an app for 2FA. But the main difference is that 2FA, Authy keeps it encrypted in their clouds. So if you lose your phone, if it gets, if it falls into the river like Jane, you can just download Authy on your new device and it'll recover the 2FA credentials from there. But the issue is, of course, if you store your Authy password in your password manager, you're creating a cyclic dependency because you need 2FA to log into your password manager. But what's the alternative? The only alternative is really to make your Authy password memorable, right, and more simple. So where are you supposed to keep the password to your Authy account? It's a serious question, and I think I really am curious what other people are doing. So if other people have found solutions to this, I'd be interested in hearing. But I haven't come across anything good for these, and except of course the PaperVault, right, with threshold encryption. So before I get into a short live demo of PaperVault, I want to touch on some of the technical design considerations I made along the way. So for QR codes, I tested with different lengths of secrets, different densities of QR codes, and placements and arrangements on the page. I tried having several QR codes on the page, as well as having a big QR code in the center, which that was what I thought initially would work best. But I settled for having maximum 2 QR codes on a vault page and having them on the on one side of the page, the left side. And that's to make it easy and fast to scan and hold up in front of the camera. So it's kind of like a UX consideration. And I also found out that if the QR code is, at least on paper, if it's too big, then there are slight waves in the page that make it harder to scan when you hold it up, right? So that's what led me to making it smaller. I mean, there are a few other considerations, like if you have too many QR codes on the page, it starts getting a bit messy, and so I put together some design constraints for myself, and decided to limit the size of the secret that goes into each vault. So right now it's, I think, somewhere in the 500 characters zone. So it's not a place you would store photos and videos, but just small secrets. And I decided on having 2 QR codes on the vault, one for metadata, which is clear text and describes how many keys there are, and the public vault name. And the second QR for the actual encrypted payload. So once I started managing several vaults and having all these papers getting printed around me, and kind of like I needed to sort through them, I realized it would be super helpful to have a way to organize the pages very easily during a key ceremony. And so that's how I ended up putting a color sequence on the top right of the page, right? That's randomly generated for the vault and its associated keys. So the vault would have the same colors as the keys. And it makes it easy to sort when you're managing binders or multiple vaults. And then finally, I gave each key a name that's easy to verbalize and say over the phone, like, hey, friend, do you have key, squad junk? I used basically the BIP39 seed words to randomly assign two words to each key as a name, so you can easily call it something without having to think about naming each one. So these were some of the design considerations that went into building this. And yeah, I guess the critical parts of the code are located in a file called encryption service.js. And the functions of interest are basically encrypt, which encrypts using AES-256, split key, AES-256 being, just the kind of like the standards that's used in banks and governments and so forth. So it's super standard on the encryption side. And then we're using a function called split key, which takes the encryption key and splits it into shares. And then a function combine shares, which takes the shares in and then combines it into a single key. And then decrypt, which uses that combined key to decrypt the vault. So the main external dependency is the Shamir Secret Sharing library from Privy. And the encryption is done in the browser's native APIs, WebCrypto, and no external library for that. So I also made it, I just want to kind of mention this because I think it's really neat. I made it super easy to chat with the PaperVault code base. So there are links in both the GitHub and website that make it like one click and you're able to chat with the code base. And this is both for security audit purposes to allow anyone to ask the code base questions, but it's also to help people figure out and think about their personal threat model as they create and set up their own vaults. So that's I think a neat feature as well. And then as a final note before the demo, keep in mind that you can go, really far with this, and almost to the same level as the institutions that we saw earlier, right? You can get tamper-evident envelopes to stick the paper in. You can get acid-free, archive-grade paper for creating the vaults, which is built to last for decades, and then you wouldn't see that yellowing on the page like you saw in my tree planting certificate from 1989. So this is kind of like the pro gear section. But okay, let's do a quick demo of creating a vault and unlocking it. And I have my my demo papers here. So my vault that I printed out earlier, as well as the 3 keys that go along with it. Right. So let me take you through the process of creating a vault and unlocking it, and it's super quick and easy. So this is the PaperVault.xyz website. The code is available on GitHub. It's recommended to install this on an offline computer and not use it directly from the website. The main reason is, it is hosted on Vercel, and should anything happen to the online hosted version, you don't want to be entering seed phrases or anything into anything that's online. So if you do use it for something super important, first copy it into your own computer. Okay, so let's create a vault. This is the vault creation form. I'm going to call it Boaz's test vault. And then I'm going to create a 2 of 3. So basically 2 keys are going to be needed to unlock out of a total of 3 keys. And I'll go ahead and I have a security checklist here just to help people out as they're thinking about this. So I want to make sure that I'm in a private location, away from cameras and onlookers. I want to make sure that I don't have any screen recording software running on my computer, such as I have right now. And I also want to make sure that I'm offline in doing this while I'm completely offline. So had I turned off my Wi-Fi, this would turn into a green box. It automatically detects if it's online or offline. But I'm going to go ahead and accept the risk of being online at the moment, just for the demo purpose. And then I have a wizard here where I can basically choose what kind of form of secret I want to enter. I'm just going to go with a basic note for this demo. And I'm going to say, wow, such secret. And then I'm going to confirm that this is the data that I want to encrypt. And then I'm going to go ahead and create the vault. And this is in the browser, encrypting the secret data and splitting the key and kind of doing what it needs to do. And then it presents me with the 2 options that I have, which are print the documents, or I can download them, right? I could download them into USB. I could do both, right? I could print some copies into USB, and I can also print some copies to my printer. So I'm going to go ahead and just show you what this looks like. You get a packet of a vault plus a few keys, right? And you just go ahead and print it on your printer, ideally connected through a cable, so you don't have to be on any network. And then what you should do after you create a vault is you should test it to make sure that it created, that everything went as expected. So similarly, in the unlock process, I have a checklist here. Do you have your encrypted vault? I have my encrypted vault. It's right here, right? I got all my keys. I have enough keys for the threshold. I only need 2, right? So I could potentially, throw one of these keys away. I don't need it. And then I'm going to make sure I'm in a secure location away from cameras and onlookers, and the same online check. I want to be unlocking my vault and viewing my secrets while I'm offline. So I have my other camera connected here, and I'm going to allow it to connect to the browser, and then I'm going to take my vault page here and just kind of scan it in. So that's the vault page getting scanned. I'm going to set it to the side, and then I have my 2 keys, and I'm going to scan them in as well. And it tells me which keys it's expecting. So it's expecting chapter music, couch quit, and husband upset. Husband upset. So I just scanned husband upset and couch quit, and then I can see that the secret in my vault is wow, such secret, right? Okay. So what I would do typically with this vault is, I would distribute the keys, make copies of the vault if I need to, and possibly distribute that. And then you have a geographically separated, disaster resilient, cold storage backup for your secrets. And I think that covers, that covers everything. So thanks everyone for coming to my talk, and I appreciate any feedback from the community on the product and the code, and test it out. I'd be happy to hear either way, if it's good, if you have negative feedback. I'm also happy to hear.